concept related to that question.
Yes, you're right.
If
Yeah.
it's previous, then 9 to 12.
Yes. That sounds good. So I will just open the PBQ. All of you have gone through the PYQ. There are two PYQs available.
Some of them I went through. One, I think the uh, latest one I went through.
Okay, no problem.
And there is also afternoon and forenoon and afternoon two papers of that.
Okay, I think the questions are similar. Questions are not different.
Yeah.
Okay, so I hope my screen is visible to all of you.
Yes.
Yes. Okay. So I will. Okay, so this is the latest PYQ which is available. Select. Okay, so this is a question which this we had done yesterday.
Yes.
Okay, so shall I solve? If anybody is having any doubt about this question, anybody wants me to solve it again? Okay, so we'll just do it fast without going through all this. Just calculate what are the number of nodes. So G1, G2, G3, G4, G5, G6. So when you make a adjacency matrix, so it will have 6 columns and 6 rows. It means it will have 6 into 636 values. Okay, so there is no problem in this question. Easy. Suppose the age of a node in ultrametric tree is 15 and n has just give me a sec, this will call. Okay. So ultrametric tree. So suppose the age of a node in an ultrametric tree is 15. So ultrametric trees are like this, and it has two children, N1 and N2. So during the construction of ultrametric tree using the UPGMA algorithm, what is the distance between the species represented by the nodes N1 and N2? So if you connect how do you construct a UPGMA? So your distance, this will become 15, this will become 15, and the total distance between will become 30. Is that okay with everyone? And in yesterday's session, I had covered this concept also, that how we build the UPGMA. Okay, so I hope this.
So had it been 3 children instead of 2, what would have been the distance in that case?
What are you saying?
So if n had 3 children, let's say, instead of 2.
So how do you build a UPGMA? So just for your this, I will just cover it. So UPGMA, you have got something like this: A, B, C, D, A, B, C, D, and then you have got distances. For example, A to B is 3, A to C is 4. This is 4. And B to C, for example, you take 4 again, and you take 4. C to D, you take 3. So this is your distance matrix. So how do you build a UPGMA? You first take a step 1. You put all nodes. You make this, and step 1, put all nodes on horizontal. Okay. Then step 2, find the smallest distance. So then what will happen? And so A to B is your panel. So A and B, which are there, they have got the smallest distance. So you build the UPGMA tree by doing this A to B, and whatever the distance is there, you divide it by 2. D by 2. So here you get 1.5. This becomes 1.5. This becomes 1.5. Is this okay?
Got it, sir.
Okay. Then
Yes.
step 3, what you do, you have got C and D here. So C and D are here. Now CD is also 3. So CD is also 3. So this also becomes 1.5 and 1.5. Okay. And now what you do, now you convert it to, now you have to find out AB. So you combine AB, C and D. AB, C and D. This is 0, 0, 0. Now to find the distance between AB and C will be A to C plus A to D divided by 2. So A to C is 4, A to D is 4. So this becomes, A to C is 4, B to C is 4. So this becomes 4. A to D is 4, B to D is 4. This also is 4. And C to D is 3. Okay, this is okay. And now you convert it to A, B, C, D, A, B, C, D, 0, 0. So this will be AB to C plus AB to D divided by 2. So this will also become 4. And the root node which is there, now A to B to C to D, you found of 4. You divide this by 2 and make the root node. So your root node will be here. It will be at 2. So what will be this distance? This distance will be 0.5 and this distance also will be 0.5. Okay.
Got it, sir. Thank you.
Okay.
Sir, I have a doubt. Can I ask?
Yes, yes, please.
Okay. So, sir, see, like, if in this case they have given the matrix, right?
Okay.
And they asked in the question that we have to give the distance between A to D. Then in this case, we'll give it as 4, right? Because the distance between A to
Yes.
D is 4.
Yes, yes.
Okay. All right. All right.
Okay.
Yes. Sir. Thank you.
Okay. Okay. Then we go to next question. Okay. In an alien world, mutations occur in every 10 million years only. An ultramatic tree is constructed on some of these alien species. If the height of the tree defined as the maximum number of edges from the root to a loop node is 5, then calculate the age of the root. So if you recollect, your ultramatic tree looks like this. These are the number of edges. So this is 5. So it means your 5 times mutation has taken place. And every mutation is how much it is taking? 10. So your total will become 5 into 10 is equal to 50 meter. Is this okay?
Sir, how did you
Yes.
conclude that every mutation is taking 10
Yeah,
from 10
then-
million years? Okay.
then we'll- okay. Next question.
So, before proceeding to next question, right? In the
Yes.
UPGN, we took an
Yeah.
example.
Yeah.
So, when we calculate a distance between A, B, and C, right? It must be AC plus BC by 2.
Yes, okay. So I have written AC plus BC. Yes, you had it. BC.
Yeah.
Yes. Yes.
No, fine.
Thank you. Thank you. Thank you. Thank you. And then we come to the question. What is the number of free parameters that are learned in EM setup for a motive finding with an assumption of motive of length 5? So this we have discussed yesterday at length. And just to revise, when we have got an assumption of motive length of 5, so what do we do in the EM? In the step 1, we make a profile of ACGT. So this is of length 5. So it will have 5 into 4 values. Five into 4. But they're asking the free parameters. Free parameters are the one, those I have to wait. Now any 3 I select, the summation is 1. So the fourth one is the it is not a free parameter. So I have to only do 5 into 3, 15. Is this concept understood by everyone?
Yes.
Yes.
Sir, can you say that one more time? The matrix will be 5 cross 4. What happens after that?
So 5 cross 4, the summation of probability of ACGT is 1. So if I have this 0 0.1, 0 0.2, 0 0.3, so automatically this becomes 0 0.4.
Yes.
So I can, instead of this 4, I can have for this only, by this only it will work.
Okay, so since the sum of the 4 values is equal to 1, we can pick any 3 values to be whatever we like, and the fourth value will be already determined.
Yes,
Like
yes,
that, right?
yes, inferred. Okay.
So in every row, we can pick three of our choice. So 5 rows, 5 into 3, 15.
So no, it is not like that we can choose. So when you are making a profile, you either say that I'm taking only for ACG and T is inferred. Okay. But for each row, you cannot do that. Otherwise, your profile, which is there, finally you have to update your profile.
Okay, so we have to mention beforehand that which of
Yes.
the ACGT we are inferring.
Yes.
Okay.
And you can go through yesterday's session. I had explained in detail the entire EM for motive finding. Okay, how it is done. Okay, even again that has not been covered in the lecture. So first you have to make a profile, then you have to do an E step, and then you have to do one M step. Okay, and you keep on doing till the time your profile converges. It means all these values, they don't change by a value of epsilon, which is very, very small. Okay.
Yeah.
Okay. So we go to next question. Consider the following hard K-means clustering. They have given these 4 points. And initial, they have given the cluster 1, they have given the cluster 2. They are asking after how many iterations will the algorithm terminate. So this is nothing, this is the basic of K-means. So what do we do in the step 1? In the step 1, we find the distances. So we take 0.1, 0.2, 0.3, 0.4, and then we find distance to cluster 1, distance to cluster 2, and then we assign it the responsibility that to which cluster it is having the relation. So if you see the 0.1, it will have 2 minus 1, 1, 3 minus 2, 1, 1 square plus 1 square is equal to 2. Whereas here it will be 7 minus 1, 6, 36, 36 plus 16, 36 plus 16 is 52. So this will be assigned to R1, 1 to first cluster. Similarly, second cluster will also be clustered to R1, 2. The third cluster, which is there, 9, 6, it will be to R3, 2 and R4, 2. Now in the second iteration, what it does, so this is the E step. And in the N step, what it happens, you update the cluster. Update the cluster. So now cluster 1 will become summation of points 1 and 2 divided by 2. So this will become 1, 4, 5, 3, 2, 5. So this will become 2.5 and 2.5. And cluster 2 will become 7.33 and 6. Now you come to step 2. Again, you do this step, and if there is no change in the responsibilities, you terminate. So when you do this, you will find that after step 2, you are terminating. Is this okay?
Yes, sir. Yes, sir.
Okay. Now, next question is a mass spectrometer generates the following spectrum for the peptide profile CILA, and this is the output from the spectrum. This is the depicts the mass of all the amino acids, and here we are using the criteria to trim the peptides in the leaderboard-based cyclopeptide sequencing algorithm is modified as follows. Suppose the algorithm is considered peptide P, let the number of elements in this is this. If its score is less than 0.575 n, then the peptide is trimmed. So they're asking which all peptides will be trimmed in this. So how do we do this? We do first here. We'll do first, for example, CI. So if the CI is there, then it will have 0, C, I, and CI. Take the masses of this. So this will become 0, C is 103, I is 113, CI will become 216. Okay, and so your n becomes 4. So this 0.575 n becomes 3. Now you take a score with this. How many are available? So 0 is available, 103 is available, 113 is available, and 216 is available. So your score is 4. So is 4 less than 3? No. So don't trim. Okay. So similarly, you do for all this. So you will find that your CIL, which is there, it will get trimmed. So this has also been solved in yesterday's session. Okay, I've given you this idea. You can do this, take the same step, and you will realize that CL will get trimmed. Is that okay with everyone?
Yes.
Okay. So which of the following statements about the EM algorithm are false? So false. The EM algorithm is guaranteed to find the global maximum likelihood. This is false. It is only local. The E step of the EM algorithm computes the posterior probabilities of the latent variables. This is true. The E step and M step are iterated until the parameter estimates converge. This is also true. The EM algorithm cannot handle continuous data. This is false. It can handle. Okay. Now we come to the next question. You are studying the signaling pathway system of an alien world. Existing literature shows that information in the alien world is transmitted in the following procedure. So you have to convert this language into a diagram. So there is a receptor protein. So this is a receptor protein in the cell membrane, transmits information to a series of 3 kinases, K1, K2, K3, that are sequentially activated inside the cell. The final activated kinase causes a transcription factor TF to get activated. So this is TF, and translocated to the nucleus, wherein the TF protein regulates a target gene. So this is your target gene. So from here we get the number of nodes and the number of paths. So if you see, the number of nodes are receptor 1, 2, 3, 4, 5, 6. So your number of nodes is equal to 6. The question they're asking, that you have to construct the underlying signaling network and want to find the most probable pathway along which a specific gene will receive the information from the receptor on the call membrane. Will it suffice to use 10 colors to determine the most probable pathway? So in this, the formula is that number of color has to be greater than equal to K, the nodes, number of nodes. If it is there, then you can have a colorful path. Then here only I will cover the probability of colorful path is equal to X permutation K divided by X to power K. Is this okay? So the probability also comes, you can solve. Then we go to next question. Consider the below matrix that represents a one hot encoded representation and input sequence by deep band. Decode the sequence and find the length of the motive detector. So see here, by seeing the diagram, we can see that there is a padding of 2. And this is the sequence. Now, to identify the sequence, remember this is A, C, G, T. A is 1, 0, 0, 0. C is 0, 1, 0, 0. G is 0, 0, 1, 0. and T is 0001. This is the hot encoding. So seeing this 0010 is G, this is C, this is T, and this is G. So we have identified the sequence. Now the tricky part is, now they are asking that what is the motif length. Okay, so remember the formula was output is equal to input plus 2 into P minus F. Instead we always take 1 plus 1. So output which is there, we apply only the padding so that your output and input length remains the same. So output and input length, they remain the same. So it means 2 into 2 minus F plus 1 is equal to 0. So here it will become F is equal to 2 into 2 is equal to 5. In the question they have given 3. Anybody can give some throw some light on this, how it is 3?
One person mentioned that here they are doing length of motif detector is equal to padding plus 1.
Sir, actually, the formula for adding padding is
Actually,
uh,
this output equal to input will never yield a satisfied result actually. Okay, and in the lecture I can share the screenshot also.
Yeah.
The motif detector length M minus 1 will become the padding. So the
Okay.
total length of the matrix equal to N plus, this is a N, plus 2 into M minus 1. So M minus 1 is equal to 2 here.
Okay.
So M equal to 3. And this notation is wrong, what I feel what you are telling is. It will give you inconsistent results always.
Which one?
This output equal to input.
See, this is the formula which is from
It will not match, right? If you are equating M equal to F, then also it will not give. You can try.
Okay. Hold on. All of us, we are discussing this, and we are trying to find, why it is happening like that. Instead of memorizing the formula, we have to understand the concept. So let's go how this concept is coming.
No, actually, it's not memorizing. In the lecture, architecture of the deep bind, professor has clearly wrote this answer.
No. On what basis he has given the answer?
Okay, you try with this notation also. You will give always end up with wrong answer.
No. I'm not debating with you. I'm just
No. Just I'm clarifying the things. I'm clarifying the things here.
Okay. So,
sir,
so
yeah,
first of all,
when
we have to understand why do we apply padding?
Because you don't need the corner.
Here, stride you have taken 2 here. Earlier you have taken 1 here. Now,
No. Sorry. Yeah. Okay, I was just covering the formula for that CNN. I was trying to write as by mistake I've written. I'm trying to find out that why this padding has been done, because we have to cover everything. That's why this padding has been done.
Yes.
So this padding which has been done. So if the sequence is, for example, length of 4, then you always make a motif which is there. First of all, they have not given us that what is the motif length, which is there. Because the motif length can be 2 also, it can be 3 also, it can be 4 also. Motif length is the length of the motif which we are trying to find.
Sir, they have given us the motif length, right? If you look at the number of rows in the data, that tells you the length of the sequence.
This is the length of the sequence.
So you can extrapolate of that, right? I'll tell you how we get this answer.
Yeah.
So I mean, from what I understood, the formula we use for calculating this matrix is the dimension of this matrix, n plus 2 into m minus 1. That gives us the number of rows, right?
Yeah. Just
now.
Just tell me the formula. I'll write it down.
N plus 2 into m minus 1. M minus 1 is in brackets.
M plus
n, number of sequence plus 2 times of motif minus 1. sequence length plus twice of motif length minus 1. So sequence length is n. In this case, 4.
This is the formula.
Yeah.
N and m reversed.
Okay.
Sir, can I share my screen? I opened the lecture part where he explains.
Yes, please. Please. Idea is to, to find again first the concept and to come to how we know the formula, but how come that formula has come. Yeah, please, okay, Aditya.
Hello. Sorry, I was muted. So here in the lecture, the professor says that if the motive detector length is 3, so the padding would be m minus 1 represented here. So if m is 3, then we will add a padding of 2, and then the length, which is n. And the total length will be the formula that he writes, that n plus 2m, which is padding on both the sides,
Both sides,
into
yeah.
m minus 1. So this is the concept that he explained in the lecture. Week 3, lecture 3, I think.
Okay, so with this, okay, we go with this formula m is equal to p plus 1. But I personally will try to find, okay, why it is there. Okay. So we can go with this formula. That's okay.
Yeah, I think the padding that, here and the padding in the CNN that we use, I think
It's different. They are not
yeah,
the
it's
same.
different. They are not the
But
same,
in
but
just
the
different sequence.
name is the same. That
Yeah.
padding name is same.
That is why it causes confusion.
Yes. Okay. So only, Madhi, I will cover certain basics here. That if the sequence is like this, and you are having a padding, for example, motif length, for example, 3, it does not mean that it is a motif like this. So again, for example, motif length is 3. So again, you convert it to
Sir, are you sharing your screen?
Oh, yes. Yeah. Oh. Okay. This is visible?
Yeah.
Okay, let's.
Actually, one more thing I just want to interrupt. Motif length and motif detector length are both same? Motif length, basically it is Kmer length, right?
Yes.
But here it is motif detector length they are using.
Detector is supposed to be less than motif.
Yeah.
So if we see the basics, just we can have a discussion on this, how we are using the CNN to find the motive. So this is a sequence we pass, and here we have got a filter we are passing, and we keep on finding the differences. So as soon as it starts increasing, the values starts becoming increasing, that PS dash minus PS, then we stop. And whatever the value is here, then we take that this is the best motive which is there. Is that correct? Okay, understanding? Anyone? Bhavya?
Still thinking about it, sir. Seems correct so far.
So with this, if I'm passing a sequence, for example, the sequence length is, for example, 4, okay, for example, and that sequence length 4 which is there, I convert it to, for example, I'm passing ACGT of, I pass 5 length, okay, GG also. So now I encode this. So instead of this, I'm passing like ACGTG, and then I have got the hot encoding for this. So I will pass 0, 1, 0, 0, 0, sorry, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and 0, 0, 1, 0. So what I'm passing these values, and then I'm doing padding so that this motive which is there, this filter which is there, and when we say the motive length is this much 3, it does not mean it is in a single dimension. So it has also got two dimension, because whatever we try, so we have got different filters here. So whatever the combinations of ACGT are there, we will try all the combinations to put those filters here. So they find from here, and then depending on the V, then we select the best motif which is there. And that is how CNN works. This padding we are using only that, so that every part of the sequence has been visited by this motif. Okay, that is only the understanding. Rest on we can go with that formula. Okay, is that okay with everyone, or any contradiction in this? Shall we go ahead? Okay, am I audible?
Yes, yes.
Yeah. Okay, so we can go with this formula. Thanks for bringing out this formula. So m is equal to p plus 1 and p is equal to m minus 1. So we can use this to find the padding and the motif. Okay.
There was a similar question where they had asked about the size of the matrix. I don't remember in general assignments or practice assignments, in which we had to find the size of the matrix that was given, this size. And in that, they had mentioned this formula, like that 12 into, I think it's general
12
assignment.
into 4 matrix, yeah.
It's practice assignment, I think.
Practice
Yes.
assignment. So
And
that
one more thing, just I want to interrupt here. If you are equating this output and input, then you will end up with a formula like 2p equal to f minus 1. Whereas in the lecture, it is shown that p equal to m minus 1. That is where we are contradicting.
Okay. Okay. So this CNN which is there, the output may be.
If you equate input and output, you will get a 2p equal to f minus 1.
Okay.
You can just verify it.
Yes, yes, that can be done. No
that is basically p n minus. Okay.
Okay. Shall we go ahead again?
Yes.
Okay. So this is the next question. Consider dynamic programming. So this in our last session, this I had solved it incorrectly. So fortunately, we have got this session. We can do it. So dynamic programming, these are the two sequences, AGT, GT, TAT, GT, and fill up the score matrix and calculate the number of entries in the matrix grid with the value of 3. We have to find out this. So how do we do this? First of all, we start and fill all the values this as 0. 0, 0, 0, 0, 0. Now we come to TA. So we take from here also, and here also, whatever is the maximum. And if this is matching, then it becomes 1. So TA is not matching, it remains 0. TG is not matching, it remains 0. TT has matched here. So this becomes 0 plus 1. This becomes 1. TG has not matching. So you are taking the maximum of this, or this, plus sigma is equal to 1 if matching, otherwise not matching. So here, if we apply this from top, 1 will come. Again, now here it is matched. So it will take 0 plus 1, maximum of 0 plus 1, 1 and 0. So this again, it will become 1 only. Does not become 2. Now we come here, A. So this will become 0 plus 1, 1. This become maximum of this. So it will become 1, 1, 1 and 1. Now T, it will take maximum of this 1, 1. And here now T is matching. So this will become 1 plus 1, 2. Here it becomes 2. And here also the T is matching. So this will become 1 plus 1 is equal to 2. And maximum of 2 to 1 is 2. Now we come to G. It remains 1. G is matching. So this becomes 1 plus 1 is equal to 2. GT maximum of 2 is 2. GG has matched. So this will become 2 plus 1 is equal to 3. Now here it will be maximum of 3 and 2 is 3. Now TA will come 1. maximum of 1 and 2, 2. Here TT has matched, so 2 plus 1 become 3. This will be maximum of 3 and 3 is 3, and this is 4. Therefore, number of 3's is equal to 4. Is this okay with everyone?
Sir, in the last row, third column, will it be 2 or 3?
This is T.
The one below that.
This one?
Yeah, that one.
Okay, so that's why, see, what is happening, this is 1, this is 2, this is 1, this is T, and this is T. So this T which is there, it adds to this.
Okay.
Okay, so this becomes 2. So now you take maximum of this, this, and this. Sorry,
Okay.
this and this, and that's why it becomes 2.
2, yeah, correct.
Okay.
Yes.
In our last session, I had calculated incorrectly. Okay. Any question on this? Okay, anyone? Okay. Now we go to next question. Can somebody mute? Okay, thank you. So this is about, we have got 3 species, and mainly they are asking use the breakpoint graph to determine the total number of minutes Jerry needs to mutate cat into Spike, and every breakpoint operation takes 1 minute. So essentially we have to find how many 2 breakpoint operations are there, which is known as 2 breakpoint distance. And how do we do that? We have to take cat and we have to take Spike. So cat is +4, +4 we make cyclic. So what we will do, we will make cat +4, +5, -1 is opposite side, -3 is opposite side, -2 is opposite side. And now you connect them with red color. Red color. This is your cat. And now you make the spike. Spike is +1, +2, +3, +4, +5. 1, 2, 3, 4, and 5. Now you join them with the blue color. This is your spike. And now from here, now you superimpose this spike on this. So how do superimpose? One tail is connected to 5 head. So one tail is connected to 5 head. So this will get connected here. 5 tail is connected to 4 head. So 5 tail is connected to 4 head, which is already connected. So you make the blue bit. 4 tail is connected to 3 head. So 4 tail is connected to 3 head. You come here. 3 tail is connected to 2 head. So 3 tail is connected to 2 head. And rest everything. 1 head is connected to 2 tail. 1 head is connected to 2 tail. So we have got 1, 2, 3, 4, 5. And what do we do now? We just rub off these arrows which are there. And now you calculate the number of cycles. So you see, 1 cycle is here, 1 cycle is here, and this is the 3rd cycle. So number of cycles you get is equal to 3. Therefore, formula is number of, or the 2 breakpoint distance is equal to number of blocks in cat and spike minus number of cycles. So this will become 5 minus 3 is equal to 2. Is that okay?
Yes.
Where is this 5 coming from?
These are the 5 are the number of this. 1, 2, 3, 4, 5 numbers.
Okay.
1, 2, 3, 4,
Number of
5.
syntonic blocks.
Yes, number of syntonic blocks.
And
Okay.
one more question. In the 3 cycles, not the bigger cycle, in the 2 smaller cycles, if there was only a blue line or only one red line, will that be considered a cycle?
No, no. A cycle has to be blue and
Both
red.
lines.
Both.
Okay.
There is a theorem. There is a theorem that there will be no lines only blue or red. If we delete two blue, two red will be added. So, yeah.
Yes. Yeah.
Okay.
Now we go to next question. The de-Bruijn graph of some linear circulation genome DNA comprises of two nodes N1 and N2 and 6 edges. 3 of them are directed from N1 to N2 and 3 from N2 to N1. To reconstruct DNA, you are allowed to start only from the node N1. Answer given below the sub questions with respect to the same. So they have said we have got node 1, we have got node 2, we have got 3 from here to here, and we have got 3 from here to here, and we have to find that, and we can start from here only. So which are possible? Is this possible? So if we see this TAT, so this means it has to be TA and it has to be AT, then only we get TAT. So if we have got these, so we will get, in the first we will get TAT, then we go from here, it will become TATA, then we come here, it becomes T, then again we go A, again we come here, T, and so this is the, so we come here TAT, we go from here to here, it becomes TATA, we go from here, it becomes TAT, then we go here A, and we go here T. So we cannot get this. This double A is the giveaway. It cannot come. Okay. Now we see the, so again here also double A is there. That will also not become. Now we see the third part, AT. So this is AT and this is TA. So in the first one, it will become ATA. Here it will become AT. Then it becomes ATA. Then it becomes AT. Then become AT. And last will become AT. So this is the correct answer. This one. And similarly, if you take TG and GT, you will get this one. So all these double ones are incorrect. Is this okay with everyone?
Yes.
Okay. Now we go. Which of the following statements are correct for this? If we are allowed to start N1 node only and the k-mers represented by both N1 and N2 are fixed, then there is exactly one genome sequence that can be reconstructed from this de-Bruijn graph. So if we start it from here only, then we will get exactly one. But if we are allowed to start from either node, the k-mers represented by both N1 and N2 are fixed, then there are exactly two genome sequences that can be reconstructed from this de-Bruijn graph. So that is also true, because from here, if we take the example of AT and TA, we will get 1, 2, 3, 1, 2, 3. So something like it will end into AT, something like this. Or when we start from TA, we will get TA. So we will get 2. Whereas again, if we start from 1, we will get exactly once. So both the statements are true. Is that okay?
Yes.
Okay. Now, next question is, your friend has sent you this code. This is a Burroughs-Wheeler transformation, and well, you have to find the correct its transformation. So how do you do that? So I will explain this here, and So what do you do? This is the Burroughs wheel transformation. So this has come from column 2. So you write it here like this: EH ID dollar L P R E A E D N, and you alphabetically you give the numbers. So this will become E1 H1 I1 D1 L1 P1 R1 E2 A1 E3 T1 N1. And now you sort them alphabetically, and alphabetically the dollar will come first to reconstruct column 1. So you will get first dollar. After dollar you will get A. After A is D. After E is E. E1, E2, E3. Then after E will be E is H. Then I equal to L, N, P or T. And now just connect them. And now you start with dollar. So this is dollar, you write dollar, and you write what is the character before it. So it is E1. Now you go to E1. Where is E1? E1 is here. After E1 is D1. Now you go to D1. D1 is I. Now you go to I. I is R. You go to R. R is T. You go to T is N. You go to N is A. You go to A is H. You go to H, you get P. You go to P1 is E. This is, now you have to remember which E is there. So this is E3. So you go to E3. E3 is L1. Now L1 has got E2. You go to E2. You get dollar. So now you finish it with this dollar when the dollar is gone. So this is your code, decoded one. Is this okay with everyone?
Yes.
It is easy. Okay. And in the next question, they have asked you the suffix. What is the suffix array of this message? Now to make the suffix array of this, you take the original one and how to quickly build it. Okay, I will just explain. So this is E L E T H A N T R I D E dollar. So you pick E first, okay, from the root node. So you have got E. Now you have got 3 E's, 1, 2, and 3. So you take all the root node. So this will give you this L, left and right is this full. This will give you front right is, and this will give you E dollar. It's dollar only. The rest, if you see, all are unique. So there are no repetitions. So for everything you will get the same. So this will become A, start from A, then D, then E we have covered. After E will be I, then H was there, H, and then we have got L, N, P, R, T. So now how do we build the suffix array? Now you have to write, okay, the positions of all these numbers. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you will start Now you sort it alphabetically. So first take a dollar will come. So like we have done this alphabetically, we have sorted out here. So from here only you can write. So dollar will come. Dollar place is 12. A place is A is 1. A place is, sorry, A is at 5 here in the original. A is 5. So now you write down all the places, and D is, for example, 10. So this how you will make the suffix array. So this will become 12, 5, 10. After D, now this E will come. E place will come. You write down E. So first is your, now you sort this also. So first okay, E dollar will come. So E dollar, E this one, E dollar is 11. Then is alpha. So this is at 0. Then T, this is 3. So this you can build the suffix array. This is okay with everyone? How to build?
Yes.
Okay, so this how you're getting the same 12, 5, 10, 11, 0, 2 like this. So step is nothing. You make the array. Okay, you write down the places, sort them alphabetically, and you keep on writing the number. And if there are 3, so then you have to sort them also alphabetically. So first dollar will come, then L will come, then P will come. Is this okay? Okay, we go to next question now. Okay, so shall we open the next question paper?
Yes.
Okay. Let's save this.
Can you please explain the last question of this paper, or the give sampling one?
Which one?
So below this, so the last one. In the
Yes.
end, it's given. So after this one.
Okay.
Yes.
Okay. If the give sampling and the randomized motive search algorithms are run for one iteration, each on the same set of random initial motives, then the output set of motives generated by both the algorithms are the same for all input instances. So this is incorrect again. So if you remember in the give sampling, what we used to do, give sampling, we used to toss a dice, and depending on the output of that dice, we used to take that motive. Okay, so Gibbs has got random to random. It has got 2 randoms. Okay, so every time it is not this, that this and this output will be same. It can give you different output.
Got it. Thank you.
I think this is same, if I'm not wrong. This is, it has got the same questions. It has got the same questions. So we take again, only one another PYQ is available. So we open that.
Some one question I think is
okay. So let's see which is the question. This is same. This we have done. This we have done. This add to spike is also same. Linear, non-linear. This also is same. This is also same. This is also same. All are same.
okay. I have means looking at another paper then.
Yeah. Okay. In case you find, you can just share. We'll solve that also.
Okay.
Okay. Now we come to this question paper. Consider the problem of finding the best scoring simple path of length k. Best is for k for each node in a terminating set T from some node in the starting S. Suppose the color coding algorithm using X colors, which are the following are the valid permission values for X. So we know X has to be greater than or equal to K. We just saw in the previous question paper. So X greater than K and X is equal to K are valid. Is this okay?
Yes.
Now we come to next. This is you are given 2 DNA sequences of length. Assume sigma to be the scoring function, a pseudo code for an algorithm that calculates the optimum global alignment score between the two sequences is given below. Fill in the blanks for algorithm appropriately. So this is based on the same thing which we had used earlier. So your number either can come from top, or it can come from here, or it can come from here with sigma with if you add, if it is a match. So this is nothing, this is I minus 1. We are following I and j. This is I minus 1 j. This is I j minus 1. This is I minus 1 j minus 1. Okay. So maximum of this value which is there, this will become sigma si dash. Si dash. So either it is coming from this I minus 1. From this place, this is ITJ. So this will become Vij minus 1. And this will become Vi minus 1 and Vj I minus 1 and j minus 1. Is this okay?
Can you explain how you got the sigma value again?
Sigma value there, this is the scoring function, sum scoring function.
How did you make the sigma s I dash?
SI means that if the SI TJ, if they are matching, for example, they have given that here is the S and this is the T. So this is the scoring function between SI and TJ. Either this is matching or this is matching. You are applying this scoring function. In this, they have not explicitly given that it will be +1. They have said, okay, there is some scoring function based on this match.
The scoring function will give either match, mismatch condition or gaps.
Yes.
Gap value, yeah.
Okay. So now we go to next question. Consider the BW matching, an algorithm that counts the total number of matches of pattern in text, where the only information that we are given is first column and last column in addition to last to first mapping. Note that first column and last column here refer to the first and last column respectively of the Burrows-Wheeler matrix or the M-test matrix. Note also that last to first, I takes the symbol at position I in the last column and produces its position in the first column. Fill in the blanks wherever indicated so that the pseudocode works as intended. So this is slightly involved. So what they are making, there is in the sequence they have given, and you have to find some matching. There is a pattern. Okay, so they have given first column, last column, pattern, and the last to first. Last to first is your mapping of the Burrows wheel, that from here to here what it comes. So I will not be solving this. It will take around 15 to 20 minutes if you start taking top bottom. But I will advise all of you, you take an example of one pattern and one Burrows wheel of some sequence which has got that pattern, and try to solve that. So here, if you do that, then you will find that here you will be taking last to first. Here it will come top index, and here it will come last to first, bottom index. Okay, this again directly they have given from the algorithm, but to solve this, in case you get stuck, what do? You take one simple sequence A, C, G, T. Okay, make a Burrows wheel like a first column of this, last column of this transformation, and then try to find like a ACG pattern. So your pattern will become ACG. You get first column, you get last column, and your last to first is nothing. It will be the Burroughs wheel transformation from here to here, and try to solve it. You will get the same answer. Now we come to next here. So this is from week 1 and week 2. Many antibiotics interface with the transfer of genetic information from X to Y, preventing bacteria from growing. Y is a polymer of Z. So this is a clue to us. X has a ribose sugar in its composition. Identify X, Y, and Z. So if you remember week 1 lectures, they had covered this, that this ribose sugar which is there, it is available only in RNA. So here it is a hint here. So X is an RNA. Second, Y is a polymer of Z. So this is the hint. We know the proteins which are there, they are the polymers of the amino acids. So your Y is a protein, Z is a amino acid, and this transformation which is taking place, this is known as translation. Okay, the process. So this is from week 1 basics, what they were covered in the theory. Now next question is, given the profile and given the sequence GTHGT, find the profile most probable former. So how to solve this? Okay, first we have to find, for example, here A3 is equal to 0, C4 is equal to 0, G3 is equal to 0, sorry, G2 is equal to 0, G3 is equal to 0, and nothing else is 0. Now this we can break out GTCTATA into 4 kmer. It will become GTCT, TCTA, CTAT, and last one is TATA. So now GTCT, here you see GTCT will become, G value is 1 by 8, T is 1 by 8, C is 7 by 8, and T is 1 by 4. So this is the value of this one. TCTA, so here T is 5 by 8, C is 1 by 8, then T is 1 by 8, and A is 1 by 8. CTAT, C is 1 by 8, T is 1 by 8, A is 0, so this becomes 0. And TAT becomes 5 by 8 into 3 by 4, which I can write down 6 by 8, and then T is 1 by 8, and then A is 1 by 8. Now this also you convert to 8, so this will become 2. So this is 14 by 8 to the power 4. This is 5 divided by 8 to the power 4. This is 5, 6, 30, 30 into 8 to the power 4. So your TAT has got the maximum probability, and that will be the most probable gamer. Is this okay with everyone?
Yes.
Yeah, okay. Okay. Which of the following are false about hard k-means? So this is about the hard k clustering problem. So it is sensitive to outlier. This is true. It is sensitive to centroid initialization. This is also true. Non-convergence, it is false. It always converges. Some of the output clusters can be non-convex. Non-convex means that it can be, what is the convex function? Non-convex means it can be like this. Can it be like this? It cannot be. Hard k mean will always give, it will try to discriminate along the straight line. So this cannot be non-convex. So this is false. Now, which of the following are examples of poor hard clustering? So here it has identified. So this is not, here we see some points here. So this is a example of poor hard clustering. Here it has identified, if it identifies here, so here we have got points, here we have got points, here we have got points. So this is also an example of poor hard clustering. Here it has clearly identified all the points correctly. So this is not a correct one. Okay, consider the following hypothetical phylogenetic tree constructed using viral sequences isolated. And the question is, which of the following is true with respect to the immediate common ancestor of the human and monkey viruses? So ancestors of human and monkey viruses. So monkey is here, human is here, but we don't know what is the time here. That is not given. So human virus is the immediate common ancestor. That is wrong. The common for both will be somewhere here. This is wrong. Monkey virus is the immediate, that is also wrong. Goat virus is the immediate common ancestor. So where is a goat virus? Goat virus is here. So that is also not common ancestor. Common ancestor between all of them is somewhere here for all of them. So rest, all the statements are incorrect. Any question on this again? Anything?
Yeah, can you once again explain this?
See,
That upper question.
the first question they are
Yeah.
asking, the human virus is the immediate common ancestor. So is human virus common ancestor? Human virus is not common ancestor. No, human virus is somewhere here. Is that understood? Okay. Similarly, they are asking monkey virus is the immediate common ancestor. And what they are checking with respect to immediate common ancestor of the human and monkey viruses. Okay. Human and monkey viruses are here. So neither this is the common ancestor nor this is the common ancestor of this, both of them. Similarly, this goat virus which is there, this is not the common ancestor of them. Common ancestor of them will be somewhere here. Somewhere
How
here.
do you define a common ancestor? Means can you
Common ancestor
identify-
means, for example, you have here and you come human virus. It comes monkey virus. So you can say this is the common ancestor. Is that okay?
Okay.
This is like an ultrametric tree. Okay. Now we come to this question. What is the limb length based on the distance matrix between all pairs of 4 species of A, B, C, and D? And we have to find the limb length of A. So how do we find the limb length of A? If we forget the formula also, what do? You make a limb length of A like this, A, and give a point at this X. Now we know that your structure will be something like this. So here either B or C or D can come. Here B, C, D can come. Here B, C, D can come. And write this as X and write it as Y. So limb length of A will be equal to minimum of, you take all the combinations. So what do? You start here B and you take D. So it will be BA plus AD minus BD divided by 2. Okay. Then you take BC. So this will become BA plus CA minus BC divided by 2. Now we have taken all. Now you change it to D. This will become BA plus CA minus DC divided by 2. You put all these values from here, and whatever the minimum value comes, that will be your answer. Is that okay?
Yes.
Okay, which of the following statements are true? So UPGMA method builds a rooted phylogenetic tree, while the neighbor joining tree method builds an unrooted phylogenetic tree. That is true. So UPGMA already we start from the roots and then we start building. UPGMA algorithm requires the distances to be ultrametric, while the neighbor joining tree algorithmic requires the distance to be additive. If we need to prove the respective algorithm can correctly recover the true tree. So if I remember, in the lecture, it was written that UPGMA, it works on the heuristic, and it can build an ultrametric tree for even additive trees, for additive, non-additive matrices. Is this correct, Bhavya? Whereas the neighbor joining can, it works for the additive matrices only. So UPGMA algorithm requires the distance to be ultrametric, while the neighbor joining tree algorithm requires the distance to be additive. This is true, but this is false. Okay, this can work for even like a non-ultrametric also. The basic assumption of the UPGMA method is that all taxa evolve at a constant rate and that they are equally distanced from the root. Okay, so this is true, because when we build the UPGMA, we consider that, okay, all of them, they are happening at the constant rate. So let's see the answer. So they have written all 1, 2, and 3 are correct. So where we have gone wrong. So first, okay, we identify it is correct. And second, UPGMA algorithm requires the distances to be ultrametric. So this is also to be true. This also we have to understand this is true. This we had identified, this is true. This we had identified, this is true. So all the 3 options are true. So only point key takeaway that UPGMA algorithm requires the distance to be ultrametric. Okay. Can we go ahead with the next question?
Yes.
Okay. Which of the following statement is true with respect to soft k-means clustering? Each cluster K can have a different prior probability of pi k. So this is from, if I'm not wrong, this is from week 7, when the professor had covered that K, that we can have, different probabilities to find out. So each cluster can have, okay, we can assign different probabilities also. So this is true. The per cluster, per dimensionality spread or width for each cluster K can be different. So this is also true. In that also he had covered that you can get even like this. So you can control the width and distance of this clusters. The per cluster, per dimensionality spread or width for each cluster K is same. This is incorrect. So only first and second are correct. So this is for the soft K means. Then we come to, in the K-means algorithm hard version, which of the following correctly represents the updated mean, which is the, you can say the maximization. And if we see the formula, we had covered in last session also, the formula is Rk to n x n and divided by Rk, and Rk is nothing, Rk is equal to summation of this Rkn. So this we have done, and now we come to consider the genome ATT, GTT, CTT, G dollar. Which of the following represent the correct suffix array for the given genome? Consider dollar to be the end of the text marker and assume that dollar comes first in the alphabet. So this we have covered in the just now how to build this.
Yes.
Okay. Okay, then we go to next question. The most widely used gap
Can you
analysis.
please solve the last one if it's not too much of a problem?
Okay. So how do we build this ATT, GTT? So we are making an array. So we start with node. Okay. So we come to, for example, A. So now you identify all the 8 this. So first it will give T, T, G, T, T, C, T, T, G dollar. Is this okay?
Yes, sir.
Okay. Now there is no A, so we cut it. Now we come to T. Now T will give me first T T T G T T C T T G dollar. Then the next T will give G T T C T T G dollar. The next T will give T C T T G dollar. Next T will give C T T G dollar. Is that okay till now?
Yes, sir.
Okay. Now there is another. So this will give TG dollar, and last one will be G dollar. Is that okay?
Yes, sir.
Okay. And now we have covered T is gone, T is gone, T is gone. Now we come to G. So now we have got G. So G will give me first T T C T T G dollar, and another G will give me another dollar only. G dollar, and then is your C dollar, and last one is also called dollar. Is that okay? And now,
Yes.
now what you do? Now you write all the places of that. So 0, 1, 2, 3, 4, 5, 6.
C, wouldn't it be TTG dollar instead
Yes.
of dollar?
Yes, yes. TTG dollar. So this will become, you can write down CTTG dollar. Is that okay?
Yeah. Yeah.
Okay. Now, how do you build the suffix array? So first you take dollar. So dollar has come at what position? 10. Then now you are building alphabetically. So after dollar, you will come to A. So this, again, in fact, again, you can write down this as ATT dollar. Is that okay? मैंने ये लिखा हुआ था स्वरूप यहाँ पे CTT मैंने दोबारा कर दिया था. Already it was there. The CTT dollar is there, ना? No. Sorry.
It's after T.
TTG dollar. Okay. So now we come to alphabetically A. We have come. So we find the position of A. So it is 0. Now next alphabet will be what? C. So C is at 6. After C, now will be G. Now we come to G. Now you see there is one G dollar and there is GT dollar. So dollar is always before everything. So first will become G dollar. So G dollar position is 9. Then GTTCT, where it is there, GTTCT is 3. Now after we have done G, now we come to TT. Now CT का कहाँ पर सबसे lowest कहाँ पर है? So TG dollar is the lowest. Is this okay?
Yes, sir.
Or I think TC also we have got, no? So TCTTG. So see where is the TCTTG. So this is the number 5.
Right.
Number 5. Now we go to TG. TG is here. TG is at 8. Okay. And now, like, you keep on building. Can you do this now?
Yes, sir. Thank you.
Okay. The most widely used gap penalty function in the sequence alignment is affine gap penalty. The affine gap penalty combines the components in both the constant and linear gap penalty, taking the form sigma plus epsilon into L minus 1, where sigma is known as a gap opening penalty, epsilon is a gap extension penalty, and L the length of the gap. So this we know formula. Based on the above data, answer the given sub questions. what is the usual relation between sigma and delta? So this is sigma plus epsilon into L minus 1. So generally what we saw that this epsilon used to be less than sigma. This used to be higher and this used to be lower.
Yes.
Okay. And this is motivated by biology. Unfortunately, I'm not a biology student. So we come to next. Okay. What will be the relationship between sigma and epsilon if we want to make the gap size as small as possible? So this, can somebody throw light on this from the biology point of view? Any biology student here?
Naman, I think. Naman.
Huh?
No, I'm not actually.
Okay, so see, logically, I cannot find any answer to this. So I will just say that if it comes, just take a, just to make the size smaller, just write it to be smaller.
Can we think of it as like the sigma was the penalty for opening a gap, and the
Yes.
epsilon was the penalty for continuing a gap. So they want the gap size to be small, as in the length of the gap should be small. So that's why they are giving this epsilon to be bigger. So the penalty for continuing a gap is bigger than opening a gap.
Okay,
So
so it is,
maybe we can think of it like that.
yeah. Okay, so it was like this, now that this is gap opening. So here it comes, for example, 5, and 1 is the penalty, and this becomes 3 minus 2. And we want this gap is to be small. Is this the reason you're giving?
Yeah, we're saying we want the gap length to be small. It's okay if a gap opens, but as long as the gap is not too long, maybe that is what they want here.
Okay.
Gap size to be as small as possible.
Yeah.
So they're increasing the penalty on gap size, whatever is continuing the gap.
Okay. Okay. So next we go. Which of the following are true with respect to additive and ultrametric distance matrices and trees? Assume that the distance matrix satisfy the usual distance matrix axioms like non-negativity, symmetricity, and triangle inequality. Also recall that an ultrametric distance matrix is any distance matrix that can be derived from some ultrametric tree using the edge weight and the paths in that tree. So they have given these statements. A 3 into 3 non-additive distance matrix is possible. So this I tried to find what is the answer, why it is incorrect. So it was given that when you got a 3 into 3 triangular distances are there, they can never be non-additive. They will always be additive. So a 3 into 3 non-additive distance matrix is not possible. A 4 into 4 is possible, we have seen in the lectures. All ultrametric distance matrices are additive, but not vice versa. That additive is not ultrametric, ultrametric is additive. In an ultrametric tree, the distance from the root to any leaf is the same. So when we come and whatever the leaf is there, the distance from the root is the same.
So 2 cross 2 is possible. 2 cross 2 non-additive distance matrix.
Ullas, really no answer.
About 5 cross 5.
3 into 3 they have given that the triangular जो inequality होती है वो satisfy नहीं होती 3 into 3 में. तो 3 into 3 में non additive नहीं होती.
ठीक है सर. Okay. हाँ जी.
Okay, I think this is the last one. Any query, any discussion? So I think
one more. I think one question is missing. You can go on WhatsApp. Someone has shared that.
Okay. Okay. ATP पे?
हाँ, ATP.
Yeah. There is a question.
ऊपर आप जाओ.
This one?
This one, yeah.
Show below is the motive detector matrix of a transition factor TF learned by Dave Pine.
Yeah, this is same. 18 cross 4 it will come. The length is 12 and the detector is 4. So 4 minus 1, 3. 3 into 2, 6 plus 12, 18. 18 plus 4.
Oh, then let's just. Just let's do this. Let's understand, because this question has been confusing us. Suppose below is a motive detector matrix of a transition factor learned by the deep binding. So A, C, T, G they are given. Suppose this motive is scanned by the deep bind along the given sequence this. What is the dimension of the one hot and coded sequence after padding? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 तो यहाँ पर आपका जाएगा, 12 will be like this, and we have to calculate the paddings only. So padding second, you have given the formula. Padding is nothing but m by minus 1.
Yes.
So this will become 3 minus 1, 2. So here 2 will come, and here 2 will come. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 plus 2 plus 2. As per that formula, it should be 16.
No, M, why you are taking 3 here?
Oh, sorry, it is 4. This is 4. Sorry, 3 and 3. Yeah. So this is 18.
18 cross 4.
18 cross 4.
Okay.
Yeah.
Hello.
Yes, yes.
Yeah, I have a doubt regarding that rectifier VB concept.
The rectifier V.
Week 10, week 10.
Yeah,
That is
rectifier.
activation function. That is as good as ReLU V minus B. It's told by a professor. Rectifier V RECT rect V subscription B is equal to V when V minus B is greater than equal to 0 and 0 otherwise.
Okay, but from our deep learning and whatever experience we have got, for example, we have got this
Now
number.
let me complete just. Then he went on to say that this is equivalent to ReLU of V minus B. So when you say ReLU of V minus B, if you take V as 15 and B as 10, whether it will be ReLU of 5 or answer will be 15. That is where I got confused.
Okay. So you want to say this is equal to rectifier V minus B?
No, this is ReLU V minus B. Yeah.
Okay.
This is what mentioned by the professor.
Okay.
So suppose if we, actually here you interchange the V and B values here. Notation.
Okay.
Yeah. So if you take, so for example, V equal to 15 and B equal to 10. So if it is ReLU 5 means it will be 5, but in graded assignment or practice assignment, I don't remember, the answer was given as 15.
Yes, yes. I remember that question in the GA, but have we asked this thing to anyone in the live session or on the discourse? Have they given us any clarification?
I don't remember, but this thing actually here. So we have to consider it as 15 or 5. That's the confusion here.
Yeah. So I will just share with you how I explained how I solved this question. I just went with the CNN principle because there is nothing. So in CNN we apply, there is nothing called rectifier. In the CNN we just apply the ReLU.
ReLU. And one more thing, but professor also he told that this basic rectifier B subscript B V is equal to V when V minus B is greater than 0. From that point of view, it is 15. Answer is 15. But when he says it is equivalent to ReLU V minus B, then it gives answer as 5. So two answers cannot be there. So that's the confusion.
But in any slide, have they written like this, ReLU V minus B?
Yeah, in that same lecture video only it is there.
Okay. So let's hope for the best. Whatever we write, then we'll keep on contesting on G space.
Okay.
G space.
Okay.
Chalo, any other question? Any other query?
I had one question regarding how to find the breakpoint. In the video from day before yesterday, there was a sequence of numbers, let's suppose -4 plus 3, something.
Okay, tell me the number, we will find it.
I don't like, can we just make up a string of numbers?
Let's
What I wanted
take from
to
practice assignment.
Okay, let's have this.
Yes.
Is this okay?
Yeah.
Okay. So we have to find here, what do we call that reversal distance, the
Yes.
reversal distance. So what do? We try to find the adjacency and the breakpoints. So adjacency is anywhere which is matching. So, and we have to do from here and we have to come to here. So when we do here, there is only one adjacency. Is this
How
okay?
do we know this? How do we know that there is
Actually,
adjacency?
there is a simple shortcut.
See,
He has told pi plus 1 minus pi is equal to 1, then it is adjacent, otherwise it's not. Simple. Like pi plus 1 is plus 2, pi is minus 3. If the difference is equivalent to 1, then only it is adjacent, otherwise it is not. It is a breakpoint.
Okay. So Surupi, I'll just explain. See, after 4, 5 comes.
Yeah.
Okay. So therefore they are adjacent.
Yes.
Okay. Now, for example, the sequence was minus 3 plus 2 minus 4 minus 5. This is minus 1 and minus 4. So यहाँ पर there is no, when I do a pass like this, there is nothing adjacent.
Sorry, I'm not understanding.
See,
Which way are we going?
No.
Adjacent is there between
Okay.
minus 5 and minus 4.
Yeah,
Okay.
there is one.
Okay. Just hold on. Just to answer Surupi ka question.
I think the way I do it is just draw a number line and compare them, because
Yes, you're right. You're right. Okay, that is the correct way. So I will just give you this example, Surupi. So what do? You make 2 passes. So first you make pass like this and try to know what are the. So is there any neighbor here on the number line? Is there any neighbor, Surupi?
No.
Okay, so this is 0. Now what do? You make a pass like this and you make a number line like this: minus 1, minus 2, minus 3, minus 4, minus 5. So when you will make a pass like this, so minus 2 and minus 3 are neighbors.
Yes.
So you get one neighbor.
Okay.
And then your number of breakpoint or the reversal is equal to n plus 1 minus adjacency. So your total numbers are 1, 2, 3, 4, 5. 6 minus 1 is equal to 5.
So when we are given a bunch of numbers, while we are traveling to the right, we increase the value of the number, like 1, 2, 3, 4.
Yes.
What if the number sequence was 1, 4,
Yes.
minus 1,
Yes.
0?
But minus 1 in this what do you call whatever the word is there, you don't have the duplication of these syntaxes. So you will have like this only.
We cannot have minus 1.
Yes. So how the professor, what he had covered and what I could make out.
In the statement, in the sequence that you have just written, 1, 4, minus 2, minus 3, 5, is there any adjacency?
Yes, minus 2 and minus 3. Just now.
Yeah, the one. Yes, this one.
No, 0.
0. Okay.
Okay.
So
So
when we are
good way to
trying to put
remember for adjacency is just check if these numbers should appear side by side on the number line.
Yeah, you can just simply subtract. 4 minus 1 is equal to 3. It's not 1. Minus 2 minus 4 is not equal to 1. Minus 3 minus 2. Simple subtraction will yield also.
It is the next number on the number line. If there is a number,
Yes.
then it is adjacent.
Yeah.
So you mentioned that pi plus 1 minus pi has to be equal to 1 for it to be an adjacency.
Yeah, this what he has written now, it's correct.
Okay. And okay.
This first and last element will be in circular, or
No.
That will always be breakpoints. You can first element you can consider as 0 and the last element as n plus 1.
Okay, always breakpoints. Then
Yeah,
fine.
no, it may be adjacents may be there, but first element you consider as 0, last element as n+1. That's what he mentioned.
If it starts with a 0 and then there is a
No,
1, that
starting
is
letter
also
may be 1 or 4 or whatever it may be, but the initial before that you have to consider it as 0, and the last one you have to consider as n+1.
The starting is never from 0 in the question. 0 and n+1 are what you add on your own.
Yeah. You have to add.
understood. If we start with a 1, if the sequence starts with 1, then we put a 0 in front of 1, right?
Then adjacents will be there.
So then that will be adjacent 0
Yeah,
and 1.
correct.
Okay. And at the very end, what do we put again?
n+1. If it is 5, then you put a 6 at the end.
Okay, n+1.
So 0 and n+1 you have to fix them, and in between the numbers may vary as per the question.
Okay. And what is the formula again? Reversal distance is equal to n-1.
n+1. n+1 minus into number of adjacents.
Okay.
No, that is number of breakpoints. Reversal distance is equal greater than equal to breakpoints by 2.
Yeah.
Yes.
That is the lower bound on the reversal distance.
Okay.
Correct.
Okay.
Breakpoint is equal to n+1 minus number of adjacency, and reversal distance is equal to number of breakpoint divided by 2.
Yes, correct.
Right?
Greater than equal to.
Greater than equal to, yeah. It's a lower bound basically.
Yeah, lower bound.
This okay?
Yeah.
Okay. So can we call it off?
Yeah.
Chalo, all the very best. Thanks for joining in. Thank
All
you.
the best. Thank you.
Bye-bye.
Thank you, sir. All the best.
Thank you.
Thank you, sir.
Thank you, sir.